Hi guys and welcome back. Today we are going to learn about handwritten digit recognition using PyTorch and a simple neural network. We do know that recognizing handwritten digits is a big challenge and there is a lot of data available for it. So we can use different Python and data science tools to get used to it. If you are looking for more videos, please head over to our channel AI Sciences and you can find a ton of videos on data science, machine learning, deep learning, and artificial intelligence. So, without any further discussion, let's get into today's agenda. We are going to start with an introduction to mnist challenge. We'll look at how we can import data in Python and do all the pre-processing. At the end, we are going to train our data, our model, and we're also going to test it, or maybe we can visualize it in another video. Alright, so let's get started. Now, first of all, we do know that the mnist challenge is about recognizing handwritten digits. So there's a lot of data, a lot of images that we have that are going to be that consist of different handwritten digits, and they can be used to perform the automation of handwritten recognition. So there's 10 digits starting from 0 all the way up to 9, and we can just manipulate them, use neural networks, and get started with it. So first of all, we're going to do the hands-on practice. That's what the agenda is, and we're going to import libraries and dependencies. Then we're going to load the data set and pre-process it. Then we're going to train our model, perform some evaluations. Alright, so let's get started with the coding, and we will be using the Jupyter notebook for this process. First of all, I have already loaded all the libraries that we'll require, and then there's some path to dataset, right? And you can just I'll print my name here, and we can make sure that the cells are running. Alright, so the cells are running, and we have a list of neural networks here. We have the image size and the number of hidden layers and all of that. So it's a simple neural network with 2 hidden layers, and the first layer is going to get the 28 by 28 input size, and the second hidden layer will have 100 neurons, then 50, and then 10. At the end we'll have 10 because there's 10 digits to recognize, so there's 10 classes, and it is a classification problem, right? So let's get started. First of all, we're going to transform all of our data set into the pre-processing, and we're going to use the transforms dot compose, right? And we are going to do the transforms dot grayscale, transforms dot grayscale. What this does is this makes the 3-channel image into 1 channel, that is the grayscale values. So grayscale channel has only 1 channel, which is equal to 28 by 28, and we set the number of output channels equal to 1. Now we are going to look at the transforms resize, transforms dot resize, and this will be image resize, the variable we have already defined, which is I think 28. Yeah, it's 28, and we'll resize it, and again we'll use the same parameter. 28 says the width, and then we have 28 by 28 is the image, right? And then we are going to do the transform to tensor. Since PyTorch works with tensors, so we are going to use that functionality as well. So transforms dot to tensor. Now tensor is nothing but a big array of, big array with multi dimensions. And then we are going to use the transforms dot normalize, and we're going to apply the mean standard normalization. These values are already given in the data set that help you normalize the data and bring about the data into the into a specific range of values, right? So it will be between 0 and 1. Next, what we're going to do is we're going to set our dataset folders. So we use the data train is in the dataset dot image folder, and you can use that as data underscore dir. So that is the directory which we have already defined here, which is local to my machine, and you apply this slash, which tells it about to go into that, go in deeper inside into that folder, right? And you perform all the transform equals that we have transforms, right? So that is how you make the train data, and you can do that the same on test dataset. So we just write it test here and go into the test folder, right? So we performed both the dataset into the different folders, and we have read the data, right? Now we are going to do the train data val data equals torch dot utils. You can do that and get the split the data into different parts, into training and validation. So we'll take the training data and split it into random split it into some ratio, whereas the split will be random, so that we don't end up with the same class in the train data, which is going to just train it for like some digits, and all the rest of are going to get into another into validation, so there will be no learning. So this is how we are going to do it, and you can just, instead of AIN, so for future references. And we have the size already mentioned here, the validation size and the train size. So we go forward and we do the same with we print the test size. So you can just say that test size equals list of the starting from 0 all the way up to test size. So that is how you can make it a number out of it, which will determine what the dataset, what the is what the length of the test size is. Alright, so we're going to use the transforms. Alright, so it says that dataset is not defined at this location, and dataset dot image folder. Alright, so we'll look into it, and it says that the data sets, it's actually sets for PyTorch. It's a built-in function. And transforms is not defined. Transforms, ORMS transforms. Yeah, so that works. And next we're going to make a subset for our test size, which will also separate from the dataset. So torch.utils dot subset and data underscore test comma test size. So this is just to make the test data size smaller, right? And maybe we'll make another tutorial where we tell you about how to do the testing of the model. This is just for training. This video is for training purpose, and we'll just look into how. So next we're going to make some data loaders, right? And it's going to be train data loader, right? And train loader, let me give me the train loader equal torch dot utils dot data loader, and we can train data, pass it some parameters and set batch size as equal to batch, that is the variable we've already introduced you with, and keep shuffle equal true, right? So I hope this works. Yeah, so we'll do the same. Alright, so it has no attribute subset. It says that there's no attribute subset, so I think it is data torch.utils.data. yeah, right. And we'll get the similarly torch.utils.data loader with the L is capital here, and it works. Alright, so we'll just copy it and make the same for a validation loader. We'll say it val loader, and this will be test loader, right? And here we're going to change it to test data, or we can say change it to val data and change this to test data. Batch size will be the same, everything else will be same, and we have our data loaders ready. Test data is not defined. Alright, so test size, and alright, forget test data for a bit, because this is actually test data. Oh. Yeah, so that works now, and you can just print all the loaders: train loader, val loader, and test loader. We'll get their values. You can do it as length of all of them, right? For example, we just put this out for a bit, and we have the train loader length, so it has 782 images. We have val loader length, which is 152, according to this split size, right? The one that we have defined here. So so now we are going to look into how to make our PyTorch model, right? For that we have different libraries, and it has different parameters. We have different libraries and we have different parameters to them. So we have imported it already here as but from PyTorch.neural networks, import neural networks, and we'll make a class out of it. Alright, so first of all we're going to set the parameters of the hidden layer. Let's call this array as C, and we say that the hidden layers are going to have 150, and the last layer is going to have 10 neurons, because it's a classification problem, right? And we also define dropout, which is another variable for the AI, for the neural network, and we set these variables first. Then we're going to make a class of net. We're using the NN module from the PyTorch library. We're going to define the constructor. Now constructor is the main function that helps make the set the important variables of our class. So it has the self variable in it, then the input dimensions, right? We call it input dim, which is equal to 28 by 28, which is 784. We have the output dim, which is equal to c minus 1, means the last value in this array, right, which is -1. And then we have the hidden dimensions, which we just pass this array, right, equals c. Alright, and then we set dropout as d. So we have set all our variables. We have set the input dimensions, we have set the output dimensions, we have set the dropout. Now we're going to set the super function, which is nothing but the but it's part of the class. This function has to be here. It helps the class identify its constructor, which we just defining here, which is init, the init function. It tells the model where to start learning, where to start the functions. Alright, so we do the self dot input dimensions equals input dim, right? So these are just the we are setting all the variables. Output dim as output dimension, and we are going to do self dot hidden dimensions, self dot hidden dim as hidden dimension. We will pass it the array. Then we'll do the current dimension, which tells it about the number of layers it's going to have. So this is a dynamically designed neural network, and it starts with input dimensions, right? It starts with input dimensions, so it knows where it stands right now, and it gets updated with every hidden layer. Alright, so we have the all of that set. You will do the self dot layers equal nn dot module, and we'll pass it the list of all the variables. So we make a for loop here. We say it the hidden dimensions, we can call it hidden dimensions in hidden dim, and we can say if a hidden dimension equals hidden dim, which is the last one, that is the last one. We say that if it's equal to the last one, what it's going to do is oops, let me clear that off. It's going to make self dot layers. This is just, we are just making it dynamic, as dropout. For last layer is going to have our dropout, and we can call it the also dropout spellings. You can set it back to our initialized variable, which is dropout. So, and this was done. So self dot layers dot append, and we append the linear layer at the end, because it's going to classify it into different layers, into different classes here. So, and at the end attach the last value, right? So that was if, and we can do else here, and we can say that do the self dot layers dot append, and do the nn dot linear and attach current, dim, and the hidden dimensions. Right, and you can set current dim equals h hidden dimensions. So I think that was for the model, and we can make another function here. We call it the forward function, right? So we pass it the self variable and another variable x. So what this does is, for layers in self dot layers, what you're going to do is start from the start and add on things. So x equals f dot add leaky relu, f dot leaky, or you can use relu. It's the same thing. It's an activation function. Activation functions map your values between a range, and you can just pass it to different layers, right? And get an output. Out equals f dot soft max, and do the self dot layers, get it equal to -1, and pass an x here, right? At the end you just return it as output, right? So that was the alright, so it says there's some problem here. Let's look into it. And so you start with the module, right? You have the def init. Alright, so you just no attribute module. So I think it has a nn dot capital M, I think it's alright, and now we have a class for it. We'll make a function out of it. We'll make an instance of this, and we call it net, right? And the next part is to set the input dimension is not defined at here. Input dimension, input self not defined. Alright, so it's self self. Right, so I guess we have just set our module for a neural network. Now we're going to do train this model, and we're going to make some arrays for it first, and you can do train and a bunch of different layers, a bunch of different variables. We're going to introduce some lists that are going to train, input some values, and we set the device equals CPU because I don't have a GPU right now, and we set the optimizer as optim dot sgd, right? So it's the stochastic gradient descent, and we set net dot parameters we set parameters for it. We set the learning rate as learning rate equals 0.001, and we set the RL learning rate, and we set the momentum as equals 0.9, right? So we're just setting some values. Criterion, you can just say criterion equals nn dot cross entropy loss, right? You set the epochs as any number. You can say 2 for this particular case, right? So we are going to get into it. So for E in epochs, right? For E in range of epochs, what we're going to do is start from 0 to 2. Since there's only two epochs, and when we are going to train it on them, and when we are going to set our correct variable as 0, right? And then we're going to do for batch index and data dot targets. We're going to get it in enumerate it in the train loader. So enumerate is going to take a bunch of different stuff out of the train loader and load it into all these variables, right? So we have data and target, right? And we set it as variable, which is another built-in function from PyTorch. It makes the the tensor PyTorch stuff and gets it into variable form. And then we are again going to do it as data and target, as we're going to set it as to, and we're going to do it to device, right? And this was the setting it into device, and also target dot to and pass it device here, right? So this was for making our data set. Now we are going to do the data into data dot view, right? Put on its resize it into the same size, and it was a capital R, so it's going to be here capital R, image resize into image resize. And then we have all this stuff ready. We optimize it, optimizer dot 0 grad, and optimizer dot 0, and we have underscore optimizer dot 0 underscore grad, right? And we get the network outputs as net out equals net out as data. So we pass, all of this was done to get the data ready in order to put it inside the network. Alright, so we have the predictions here. We do the pred equals net out dot data dot max. We max out the data, and we have to calculate the loss equals criteria into net outputs, right, and compare them with target variables. So, and then do the back propagation as loss dot backward, right. So we are going to do all the stuff. We're going to do back propagation, we're going to do optimization, and we're going to make a step out of it. So we say that if batch index is divisible by 10, do this stuff. If it's equal to 0, we are going to print epoch name and batch index, and also print the loss. So it is loss dot item, right. We can further clean this up, and we're going to put some train loss underscore array and append it to loss dot item, right. So this is how we're going to train the model. So let's run it, and say it says train is not defined. Alright, so let me just remove this, and it says the layer is not defined at. Alright, so it must be layers, right, not layer. So layers, and it says epoch is not defined, so we can say, alright, what line is it? Print epochs. So we'll call it E here, right. So the model is training right now, you see, and it's going to take a while for this. Once it's trained, you can just let me just restart the kernel. Once it's trained, you can just take the trained model, and you can do the torch dot save. You can do the net dot state and make a dictionary out of it and give it a path, right. We can say wait.pth. So you can save the model here, and you can load it anytime. So that was for training, and we'll make another video on how to visualize this data, how to test the data. If you want to learn more about AI and machine learning and deep learning, don't forget to visit our channel, and also support us by subscribing and liking this video. Hope you've learned so much today about mnist challenge and making dynamic layers in your neural network. So hope to see you in the next video.